Okay, so today we are looking at angles and circles. So we're on to a new chapter. And this is all about something fancy called trigonometry eventually. But for now, we'll just start off from the basics, hopefully. And hopefully I won't confuse you. Okay, because it's not so bad. So to begin, we're going to learn about angles. So what is an angle? An angle is a measurement or a measure of rotation. But it's better understood just through pictures. So the idea is something like this. If you have a little ray like that, aka an arrow, and I guess I'll call it A, and then I sort of twist it around until it moves over here, which I indicate with a little in-between circle thingy. The angle is how far I have to rotate A until it becomes B. So since I'm going from A to B, we even draw this with a little arrow like that. You don't have to, but sometimes you do. And the angle itself, aka how far it is from A to B, we need to name that, and we call it theta. So it's a Greek letter called theta. And you can use other letters to label angles too, but that's the first letter you usually use. And the idea is that theta is, like what I just said, how far you need to rotate A until it becomes B. Oops. So that's what an angle is. It's how far that rotation is. So then we call theta the angle between the two lines that you're talking about. So in this case, between A and B. That's how you use this new notation. And then another thing is that because I'm going from A to B, sometimes you might call this like the initial side of the angle. You might call this the terminal side. These fancy words are sort of just distractions from what you really need to do, so don't worry too much about them for now. What we need to do now is learn how to measure these angles. So like how big is this thing that I drew? So intuitively, you can like compare. So if I drew an angle like this, I hope you can say like, oh yeah, that's definitely smaller than this angle. So intuitively, we should be able to measure like things so we can say which ones are bigger, which ones are smaller. And so that's what we do next. And we do it in two different ways. So we got to learn both ways. One of them is something you're very familiar with in real life, probably. But the other, maybe not so much. So we measure angles in two ways. The first is through something called degrees. And we play a little trick here to figure out what a degree is. Instead of saying what 1 degree is, that's kind of hard to do. We think about what would happen if I rotate all the way around, because that's more of a standardized thing. So that's what we're going to do. So what we do is we define 1 complete rotation to be some amount of degrees. And then 1 degree is just dividing that up. So how many degrees we want 1 full rotation to be? So we define 1 complete rotation to be 360 of these degrees. So you may have heard of degrees before in the context of like skateboarding or something. If you like spin around all the way, you've done a 360-degree rotation. That's where that is the same as these degrees. So 180 is rotating half of the way around. And so the genius of choosing 360 as one full rotation is that 360 is very divisible by lots of numbers. So if we know that one rotation is 360 degrees, it's easier to figure out what a half a rotation is because I can divide 360 by a half. I could also divide 360 by a fourth or a fifth. So it's really easy to figure those things out. Whereas what would have been bad is I'm going to invent a unit and I'm going to say like what's another? I'll use the letter B, a degree instead of a degree because it's bad. A degree is one rotation. So then you're saying like, okay, if I rotate all the way around, that's one. But then that's kind of annoying because if I want to rotate, if I want to know like, what's this angle? Then I gotta like think in terms of fractions. Like, oh, it's 1 divided by, I don't know, 1 over 100 or something like that. So it's like super annoying. So instead, we don't do anything like that. We say this, we say one full rotation is 360 degrees. That way, all of the other rotations are really easy to figure out. So here, this theta equals 360 degrees. And then a half rotation, how many degrees is that? That's got to be 360 divided by 2. That's what it means to be a half. That's 180. And I don't have to deal with any decimals or fractions. And what does that look like? That looks like starting here and rotating half of the way around. So this flat line is a 180 degree rotation, or a 180 degree angle, I mean. And then a quarter rotation, aka a half of a half, would be 360 over 4, or 180 over 2, aka 90. That would be, instead of going half of the way around, go a quarter of the way around, and it looks like that. This angle is so special that sometimes you draw a little box here to indicate 90 degrees. It's also called a perpendicular rotation, perpendicular angles. It just comes in handy a lot, so we'll be using that a lot later. And then we can also do more than one rotation. Sorry, I didn't write, this should be 90 there. Okay, so we can also do more rotations, meaning if I start with the line here, if I go all the way around, that's 360 degrees, but I could go around more. I can go around a second time, and that would be 720, because I do 360 twice. Or we can do something like this, go around once, that would be 360, and then don't go around all the way again, maybe just go up to here. So that would be 360 plus 90. What is that? 4,500, 450, right? So one thing to keep in mind is that 450 degrees sort of looks the same as 90 degrees. They are really like the same in a certain sense. And that's something to think about for later. So we can rotate more than once. You can do 3 times, you can do 1,000,000 times, you can do it whatever you want, but we can also rotate backwards. So what we're doing right now is we're saying if you go in this direction, like that, maybe I'll do it slower. If you go in that direction, that counts as a positive angle. So a complete rotation of that direction is 360. But if we rotate backwards, I can do something like that. Then this angle, we would count as negative. So this would be negative 90 because it's a quarter rotation in the backwards direction. And then notice that would actually like be exactly the same as if I went this way. How many degrees? 270. Because right here would be 180. And then 90 more is 270. So the point is that there's lots of ways to say the same angle. So 270 is the same as negative 90 in terms of degrees. And I keep drawing them from the specific starting side, initial side like that, and then drawing the terminal side somewhere like that or something. So I'm always doing that. But that's just because in the future we always like it to look like that. But really, it can look like many other things. So angles can look like this, for example, or that, or something down here. Something like that. So I always draw the initial side going like in this direction, if you noticed. I tried my best. This one's kind of crooked. And that's because what comes next is we always think about angles, not just in the middle of space doing whatever they want. We always think of them in terms of the XY axis in this section. So that is what we're going to do from now on. And there are reasons for that. So if you study geometry, then you don't really have XY axis stuff. You just have shapes. But in this class, we like the XY axis. So we typically do all of this on the XY axis in the following way. We declare the positive x-axis to always be the initial side. And we measure our angles from there. So here's the XY axis. And what we say is that this is always the initial side, and all the angles we make out of it on the XY axis are assuming that. So I could draw 90 degrees, and that would be this thing. Or I could draw 180 degrees, and that would be this thing. So if I say a 45-degree angle, or I say a 90-degree angle, I don't mean like a different 90-degree angle. I always mean this one. And if I say 180, I always mean this one. And I'm running out of colors. If I say 270, I always mean this one. And if I say 360, I mean that one. And so we do everything on this XY axis where this blue line is always the initial side. Okay? So what we also say is that this is the 0-degree angle. Because you can think of it as if I don't go up at all starting on that blue line, that means I don't rotate at all, so I rotate 0 degrees. So then in that situation, 0 degrees is the same as 360. Okay, so let's just practice drawing some more angles. So if I say draw theta equals 45, I don't mean draw whatever 45-degree angle you want. I mean draw the one where you assume that the x-axis on the right is the initial side. So where's 45 degrees? Well, 45 is 1/2 of 90. So if I know where 90 is, which I do, I just have to cut that angle in half. So 45 is just halfway up to 90. And then I could draw, so let's do another picture. So what about like, how about 225? Well, the way to draw this one is to think in terms of numbers that we know about. So we know how to draw 90, 180, and 270. So really we should think about this as 180 plus 45 more, and that's the best way to do it. So where is 225? Well, I go to, there's 180, And then 45 is a half of a 90-degree rotation, so it's halfway. So this guy there is 225. Okay, and then again, we can go in the negative direction. So like if I said draw negative 45 degrees, that would mean draw this one here. Halfway down to negative 90. This would be negative 90 if you went all the way like that. Okay, so you can draw angles forever, a lot of fun, but unfortunately, you got to grow up sometime, and so only babies use degrees. So when you're a baby, you use degrees. But we're all in college now, so we're going to grow up, and we're going to use radians. Radians are cool. This is what everyone uses. This is what the Zoomers do. They like radians. So they're cool, way cooler than us millennials. So that is what we're gonna do. And that is what you are gonna have to learn how to do. So the second way, this is the second way to measure angles, is using radians. And we play a very similar trick. I'm not going to tell you what 1 radian is. Notice I never told you what 1 degree is, because 1 degree is ridiculous. It's too small. Instead, I'm going to say how many radians there are in a complete rotation. So we declare, I do declare, that 1 full rotation, 1 complete rotation, is this many radians. How many radians? It's going to be 2 times pi radians, where what the heck is pi? Pi is this fancy number. And it's the ratio of the circumference to the diameter of any circle. This is what pi is. So it's always the same, which is weird, but that's what happens. And that is what we are going to think of as 1 full rotation. Okay, so same picture as before. This angle, instead of calling it 360 degrees, we call it 2 pi radians. You don't really have to write radians because I'll know that you're talking about radians, because only a baby would ever use degrees after this lesson. So I don't really care if you write the units. I'm going to know you're talking about radians because that's what we are always going to use. So then this guides the rest of the angles. Same way it did for degrees. So this guides the rest of the angles. What I mean is, what are some like important angles? Well, a full rotation is certainly important. That's what we said 2 pi was. Well, a half a rotation is also very important. So what's that angle? Well, it's 2 pi because that's 1 rotation divided by a half. So that's just pi. And then a quarter rotation, same idea, and we're still going to use that little box sometimes. That's 2 pi cut into fourths, or you can think about it as a half of a half rotation, aka pi over 2, because pi was already a half rotation. And then we sort of have to be good with fractions to do these other ones. So that's okay if you have forgotten how fractions work. So what would this one be? Shoop. Well, that looks to me like pi, because this would have been pi, plus a quarter rotation, aka one of these guys, a 90-degree angle. So pi plus pi over 2, that's 3 pi over 2. And again, we can rotate backwards just like before. That all works the same. But what we're going to do now is we're going to label all the best angles that we need. Okay, so I think we should do that. Hold on, sorry. Yeah. Okay, so what would the 45-degree angle look like? So let's turn degrees into radians. So radians are better, I claim, so we better figure out some nice angles. Okay, so now we're back on the XY plane. So this angle here, we already figured out that was 45 degrees. But what about in radians? How many radians would that be? Well, it's a half of 90. What was 90? That was pi over 2. That was up here. So we're still doing the same thing. We're just cutting things in halves to figure this type of stuff out. So this is pi over 4. So then like let's do another one that we did already. So what about this guy here? I think that was 225 degrees. What would that be in radians? That would be, well, pi gets me to a half rotation, and then I'm adding another 45 degrees to it, which we just said was pi over 4. So that's 5 pi over 4. So there is a little formula to translate from degrees to radians faster, but it is also good to think about it in terms of pictures like this. But I guess we might as well see that shortcut. So we can convert between degrees and radians by using this, using that 360 degrees equals 2 pi radians. So then all you have to do is divide one side over the other. So you can say that 1 degree is 2 pi over 360 radians. So then that means if you have some amount of degrees, say I have 225 degrees that I want to turn into radians, all I got to do is multiply it by 2 pi over 360. And you can do some cancellation on your own and you'll end up with pi over 4. So, or sorry, not pi over 4, but 5 pi over 4. So that's the way to turn degrees into radians, and then the way to go back is to divide the 2 pi the other way. But we're not going to do this very often, so don't worry too much about it. So 360 degrees divided by 2 pi is 1 radian. So that means if I want to know, like, okay, how many degrees is pi over 4 radians, I just have to multiply pi over 4 by this ratio. So we already know the answer better be 45 degrees, and it will be if you do this. So the pi's cancel, and then 360 over 8 is definitely 45. Okay. So the other thing to do is to figure out some information about the really, really useful angles. So next, we need to convert 30 and 60 into radians, 30 and 60 degrees. 30 and 60 and 45, we already did, are the most important angles because they create nice triangles. That's really the secret. So don't tell anyone yet, secret. These make nice triangles. That's why they're so important. But don't tell anyone. Shh. Okay, so that means that we need to know what these are in radians, because radians are going to turn out to be more useful. So 30 times 2 pi over 360. So let's see, that is 30 pi over 180, which is pi divided by 6. So pi over 6 is 30 degrees. And so where's 30 degrees on the XY axis? It's just, it should be super low down here, I suppose. So that's what we're talking about. This angle is pi over 6. And then we already found pi over 4 was 45 degrees. So that's what this one is. And then 60, we don't know yet, but it's going to be up there. So let's do it too. 60 times 2 pi over 360. That's going to be 60 pi over 180. That goes into it 3 times, so pi over 3. So this guy is pi over 3. So those 3 angles are the most important angles because they make nice triangles for us. And then the nice part is everything is very symmetric. So there are going to be angles that sort of look like 30, 60, and 45 in the other quadrants. So people call these things quadrants. And they say this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then the idea is, hey, this guy is 30 degrees, aka pi over 6. Well, this one right here looks sort of the same. If you're like upside down, it's sort of like, oh, this is 30 degrees also. And they are related to each other, so that's what we're going to think about later. But the main point is that these 3 angles, let me do it like this. These 3 angles that we just figured out, 30, 45, and 60, are all going to have corresponding guys in the other quadrants. Like that. And then also here and here. So those, all the white ones there are corresponding to 30 degrees, aka pi over 6. All the blue ones are corresponding to 45 degrees, aka pi over 4. And all the red ones are corresponding to pi over 3, aka 60 degrees. Okay, but that is something for next time. We'll be using them a lot, so keep it in mind, but don't worry, I'll go over it when we need it. But for now, what we're going to do is we're going to draw some triangles. So how does all this relate to triangles? So given a nice angle, so what's a nice angle? It's in quotes because it's not well defined. I'm just being vague. A nice angle is one where you take good selfies from. But that's in real life. So in math, a nice angle are the ones we just talked about, like pi over 4. But there's other ones. I'll just remind you of 45 degrees, but eventually you have to get over the degrees and just think about radians. So given a nice angle like this, if we cut off the line, so instead of just drawing an infinite line like that, we cut off the line and we say, okay, just stop right there. Cut off the line. So it has length 1 instead of being infinitely long. What happens is we get a triangle. But not just any old triangle, a right triangle. By dropping a straight line down to the x-axis. So it's a right triangle because this angle here is 90 degrees, aka pi over 2. And if you remember what happens with triangles, the total angle has to add up to 180, aka pi. And so that means if this is pi over 4, aka 45, it's got to be a 45, 45, 90 triangle to add up to 180. So we get a nice 45, 45, 90 triangle, which has nice properties. The total angle is 180, which is pi, so you can think about it in that way as well. Pi over 4 plus pi over 4 plus pi over 2 adds up to 1 complete pi. So if you do that with 45, you get a nice triangle there. You can also do it with 30 and 60. That's why these are the nice angles. So if you do pi over 6, aka 30 degrees, you get another, oopsie, you also get a triangle that I can't draw very well. Sorry, let me one more try. Okay, close enough. Okay, so pi over 6. So if this one's 30 and this one's 90, then to add up to 180, that's 120 already. So this one has to be 60, aka pi over 3. So that's a 30, 60, 90 triangle. Also a very popular triangle. Then if I just sort of think about that one as like being rotated a little bit, where now this angle is on the bottom, and that being pi over 3, aka 60, then this one will be pi over 6, aka 30, and I'll get another 30, 60, 90 triangle that has important features. Okay, so next time we are going to talk about these triangles in more detail, and then we're also going to talk about the unit circle. Okay, but that is it for this lecture.